Good morning to one and all. Today my Techtalk topic in power system production is busbar protection schemes for different distribution substations. And busbar plays, coming to the topic, busbar plays an important role in power transmission and distribution. They are employed as a central distribution point for all feeders. In the case of fault, current on busbar production becomes high, resulting to mechanical destruction, which would affect all feeders. Here is the diagram for protection in the power transmission and distribution substation. The problem is that the bus bars are usually left out without specific protection because it is assumed that have highly reliability. It was feared that if a bus bar had a dedicated protection scheme, it might maloperate and end up affecting the whole power system. The other reason was that backup protection was assumed to be good enough to provide decent bus protection due to problems such as loss of loads and long time to clear the faults. When using the backup protection, a dedicated bus bar protection scheme is required. When it comes to a dedicated bus bar protection, the high speed in operation, reliability and stability is in demand. Instability of the power system might be caused by case of failure to trip during an external fault or false tripping during service of the bus bar. This will lead to complete blackout. This technical article explains the bus bar theory at the distribution network level. It also covers the bus bar protection schemes that are currently in use and their operation. There are number of protection schemes that are employed for bus bars. The most used are as follows: system protection used to cover bus bars. Frame earth protection, single bus bar frame earth protection, frame earth protection, sectional bus bars, frame earth scheme, double bus substation, differential protection for bus bars, high impedance differential protection, low impedance differential protection, and sectional bus bars, location of the current transformers, reverse blocking and interlocking protection. The scheme for a system protection is used at a small size power station, and detailed explanation for the frame earth protection, differential protection and reverse interlocking protection for bus bars is discussed further. Number one is system protection used to cover bus bars. The system that is used to cover bus bars consists of over current or distance protection. Making use of this system will be inherently protected. The system also can be used as backup protection by using time grading. In case where slow protection action is required, time grading ensures that the circuit breaker nearest to the fault always opens first by choosing an appropriate time setting for each of the relays. A simple radial distribution system as shown in figure to illustrate the principle and is well explained in this technical article. Here is the picture, the figure radial system with the time discrimination. Coming back to the contents of frame earth protection. Frame earth protection for bus bars has been extensively used in the past. This method can be applied to various layouts of bus bar protection and each leaving a certain capability. Frame earth protection schemes are still in existence and provide effective services for bus bar protection. Introduction of numerical relays has added to decline in application of a frame leakage system. Let's explain the protection schemes of the following frame earth protection options. Single bus bar frame earth protection, and a frame earth scheme in double bus substations. And next one is single bus bar frame earth protection. This protection scheme in a single bus bar layout is seen as the earth fault system and is utilized for the instantaneous relay in the figure 1, energized by the current sensed by the circuit that is mounted on the earth conductor. It is important that no other earth connections are allowed to link to the structural steelwork. This guarantees that the circuits and the principal earth connection are not shunted because that behavior might result in increasing of the effective settle, leading to the possibility of maloperation of the relay. It is critical that the switchgear should be insulated from the ground by making use of concrete as a foundation. Here is the figure that shows the single bus bar frame earth protection. There are some of the parts that contains triple circuit breakers and frame earth fault relay. Here is neutral check relay and circuit breakers. The whole is contained with switch gear frame. And coming back to go back to contents, frame earth protection, and that means sectional bus bars. The system divides the bus bars into sectional, and protection is also done separately. This is done by dividing the frame into sections, each using a dedicated earth conductor. Each section consists of a separate circuit and a protection relay. These sections are now treated as a separate zones as shown in figure 2. The system is arranged in such a way that the protective relay one time only trip when the fault is within its respective zone. Here, Zone A and Zone C and Zone B are captured by insulation barriers. Zone A frame leakage relay, Zone B is a frame leakage relay, and the figure showing the earth protection sectional bus bars diagram. Coming to frame earth scheme double bus substations. In this system, protection is provided as single bus insulation with additional drip circuits connected to the auxiliary bus as shown in the figure to operate for all the faults. A check system is used to provide security to the equipment against events caused from operation due to human error or mechanical shock. This check system is not applicable for small equipment. If the low voltage wiring is faulty, the check system must prevent the operation caused by the current passing to earth via the switchgear frame. The operation is providing by energizing the protection relay using the neutral current. If the check system for the neutral is not offered, the frame earth relays will operate after a short time delay. Coming to differential protections of bus bars. The differential protection operation directly uses the Kirchhoff current law, where it required that the currents going to a node are equal to current leaving the node, and the sum of the currents is not equal to 0 by comparing their magnitude or phase. The difference is referred as the fault current as shown in figure 4. Let us observe the figure for a minute. Is it okay? Then when the bus bar has a fault, also known as internal fault, the total current entering is not equal to 0. Fault current is the sum of all currents. There are numerous methods can be used to apply the scheme. The below figure shows the arrangement where one of the relays is employed with several circuits connected in parallel. This method is also useful for earth fault protection system for a bus bar. An additional protection by phase faults can be achieved by connecting balanced groups. In order to have a good performance for the scheme, it is recommended to configure the phase and earth fault settings to be identical. Coming back to the contents, high impedance differential protection is one of the type. It is a high impedance has been in use for over 50 years because of its robust, fast and secure operation. This scheme makes use of the voltage across the differential junction points. The disadvantages of the scheme are that it requires dedicated circuits, which adds extra cost. During a bus bar fault, it requires an additional voltage limiting resistor that it is utilized to observe energy. Take a look explanation in Stephen's video. Here is the video. We can observe high impedance bus bar protection. We use many different types of bus bar protection on the transmission system. The one we will focus on this course is high impedance bus bar protection. High impedance bus bar protection shows the diagram. We all know it. Then the next is differential protection for sectionalized bus bars. When a differential protection is employed for sectional bus bars, it is required that a divided bus utilizes separating circulating current. Zones are used to divide the sections and decided in such a way that they are overlapping across the section, such as the figure 7 shows it. And the next bus protection is location of the current transformer. We all know it. And the special protection needs to be provided to detect short zone and a trip signal to be sent in the next upstream. These are the figures shown below. Reverse blocking and internal protection. It is also same as a fault occurs. It was cleared by time delay protection upstream relays. And the advantages we all know it. One of the advantages is modification for the screen to suit substation extensions are easy. The figure shows the illustration of the interlocking system, and If you have any references, an innovative law implements bus principles application by GE, you can approach network protection and automatic guide by GE, Alstom grid. Uh, this is what I'm here to explain. Thank you for giving this opportunity.